overview, sort of walkthrough of ThreadNet, kind of quick as I can. So we launched ThreadNet with this command. It'll come up in your browser. I'm going to load a file, 1 day, 1 clinic. This is the test data that's available on the website. When you see this, it gives you your sort of overview of your entire data set. You could select here, if you wanted to, a particular subset of it. Gives you a chance right there to narrow down the amount of data that you're using. You can also choose which columns you want to include in the data, right? Which can potentially speed things up. The key thing about ThreadNet is once you've read in your data, you need to choose your point of view. So the point of view involves defining what counts as a thread, what's going to provide coherence to the data. So let's choose visit. When we choose visit, it gives us a little pie chart here that shows that there's 25 visits in this 1 day at this 1 clinic. You can also choose threads that are more specific. For example, you could say within each visit, I want to look at not just the visit, but also the role. So within each visit, what did each, for example, the resident, the technician, the physician, staff, registered nurse, and so forth. So by choosing the thread, these are the things that stay the same within the visit. Let's do the obvious thing first, just pick threads. So the next step is to define the events within the thread. These are marked by contextual features that change within each thread. You got to pick one. So let's, again, pick the obvious one, action. But we could also say, you know, I want to see what action is performed, not just that, but who performs it and what workstation they use. So when you do this, here's our roles again, resident, technician, and by the way, the colors here are chosen by the software. They don't mean anything. Don't try to think too much about the colors. The workstations are just the labels on the computers, and combined, this results in a large number of different specific actions by particular people with particular tools. It's like these are the people that use tools to do tasks. So from that, we have an opportunity next to, again, select a subset if you wanted to. You have to go through this step of visiting this screen because it computes this combined action role workstation. It basically is converting the occurrences into a different internal data structure. And then you can save that point of view. You can relabel it here if you want to, something else. You know, put a name on it if you want to and save it. Once you've saved a point of view, then it opens up all these other choices and options about what to do with the data analysis. So for example, you can visualize the threads. This is a little graph that's inspired by the work of Daniel Geiger and Anja Danner-Schroeder. Each one of these lines here is a thread or a trace. If you just want to look at a few of them, you can narrow it down. When it's horizontal, so the x-axis is the relative time, the y-axis is the number of occurrences, the number of things that happen, and it kind of gives you a sense of how quickly things are progressing. Right? Go back to see all the data. It shows you like this. So there's a range of different kinds of visualizations. I just want to show you quickly. You can look at the whole sequences. Sometimes these things take a second to pop up. So these are the same 25 visits. They all start with check-in, and they usually end with print, this AVS print time. You can also look at them in terms of the actual time that they occurred. And when you do this, it gives you, you know, over the course of the day, right? Or the relative time, which just shows how long they occur in clock time. So the difference is this is like clock time, I think in seconds this is, versus event time, right? So then you can, again, just if you want to see it here, visit your pie charts again for the contextual factors. N-grams shows the subsequences. An n-gram is just the number of sequential occurrences that you can see here. A little hard to read that, but you can look at things that occur 3 in a row, 4 in a row, and so forth. The event network in a circle layout just looks like a horrific thing. You can zoom way in on these things and it shows you the labels if you want, or you can look through the labels here and pick out one particular piece. You can also filter this out to show the edges that are the most frequent. So all of a sudden all that complexity goes becomes much simpler. Okay, so that's that. Within each of these graphs, you have an option of zooming if you want to. So zooming will change the number of occurrences in the graph. It's kind of hard to see that it's doing that, but if we zoom way in or way out, you can see and display the edges above a certain level. You get a sense of how this graph is changing. So this is the circle layout. You can also look in terms of an event force layout. This kind of grows or evolves as it works out where to put the nodes. If we draw this, if we color the nodes according to workstation, take it a second to redraw, you'll be able to see that the clusters of activity tend to correspond to workstations, which makes sense within a routine in a clinic. That's kind of cool. You can zoom on this graph as well. When you do that, let's go back out. Right, it shows you the whole thing. And you can, actually I want to zoom to a medium amount here. When you do that, you can click on particular nodes and it shows you what's inside that node. Like that one is a sort of pure case. If we click on, if it's a node that has sort of a combination of actions, roles, and workstations, it'll show that. Like this one is likely to be a mix of things. There we go. So this is all interactive and just allows you a way of looking around in your data to see what's going on. This is, I should have mentioned, this is a particularly complicated set of actions. These visits vary in length. They have an enormous number of different events that occur. So it's really a pretty extreme case. So the patterns that we're seeing here are hard to discern. Oh, so here we have a little error. Like, oh, look, it's annoyed at us. It's oftentimes you can recover from those things by just clicking on something and it'll sort of jump back into line. That's an example of a kind of small bug that will come up occasionally. So circle layout, force layout. You can also look at regular kind of networks, for example, networks of the actors, like staff, technician, administrative technician, physician, and again, filter out by frequency which ones are most common. So this is the co-occurrence of these different roles within a set of threads. You can also look at like role maps, like who does what. Sort of shows you the network of which actors are doing which actions. So that's good. So that's sort of the basic visualizations. Within each type of visualization, the whole idea is to be able to compare. So in order to make this most fun, I'm going to go back. Like right now, I just have one point of view to choose from. I'm going to go back and make another point of view. So I'll say I still want to look at visits, but I'll define events just by the actions, okay, and leave out the workstation and the role. And if I do that, I'll come here and save that point of view. Then when I'm coming back over to the comparisons, I can choose which point of view I want to look at. And I can compare how things look from these two different points of view. Now, you can see pretty clearly that regardless of how you define the events, there's the same number of them. Like these different bars are about the same length, right? But if we dive down in and say, I want to look at this one in terms of the circle layout, right? When you define the actions just in terms of the actions, you have far fewer. Like here, there's only 48 different actions, where here there's 458 different kinds of events when you take into account the actor and the workstation, right? So this kind of comparison is the key thing in ThreadNet to be able to compare things. You can also look at comparisons. Oh, as long as we're here, let's compare this. We're going to compare by diagnosis, and let's compare acne to contact dermatitis, and we'll compare engrams. Let's see if it works. Oh, it's only got one going. I didn't do this in advance, so there we go. And we'll pick a different. Right. So this is within a given data set. If you have you need a few dozen observations, you can look at different perspectives on the data over time and by subset. So things like this. The whole point is to facilitate comparisons, right? Okay, so the moving window is intended to facilitate comparison over time, right? And within this particular day at this particular clinic, things are pretty much the same. You can adjust the size of the moving window. You can adjust how far you want the window to move from one step to the next. You can pick a different visualization. Right. Currently, these are looking at the same location, but you can move the window and say, oh, here's how this is changing over time. So there's a lot of stuff you can do here. I think I'm going to stop there. There are a variety of what I think of as advanced features to do with chunking and clustering the data. In here, you can, for example, take your data and create a cluster solution that allows you to zoom in and out in different ways. You can find and replace patterns within your data. So if you start with, for example, this solution here, and I'm just going to do something kind of silly, pick a few of these, and have it drop things that don't fit. It takes the data and looks for these common patterns and then replaces them in the data, so you can see which subsequences are most common within the data. So that's kind of a cool thing. In here, you can also export and delete different points of view, and so forth. So there's lots going on. Acknowledgements. This is a work that's been supported by the National Science Foundation on our project on antecedents of complexity in healthcare routines. I've had help from some of the people at the MSU data analytics group, like Danielle, Patrick, and Ezra. Lucy Yuhan is an MS analytics student who invented the original algorithm. Others here have contributed as well. My collaborators, it's a long list of people who've influenced my thinking and helped me out with the work. You can, of course, visit the website for related publications. There's a whole other version of ThreadNet that includes a lot of computational metrics and complexity metrics and things. And of course, don't forget to see the official song. So, hope you're enjoying. Thank you so much. I'm going to wrap this up. Oh, wait, I want to show you real quick. So here's where you download. So ThreadNet, routines.bro.msu.edu, ThreadNet. So ThreadNet 3 is the shiny R version that we were just looking at. ThreadNet 2 is the MATLAB version. You can go to GitHub, look at the issues, see what's going on. If you're excited and want to contribute, by all means, please feel free. And so forth. Thank you.